Besides nucleophilic addition reactions to carbonyl groups such as aldehyde and ketone, these can also undergo several another reactions such as aldol condensation, Cannizzaro condensation reaction, Claisen-Skimmed condensation reactions. Today we will discuss about aldol condensation reactions and what kind of intermediates and products have been formed in this reaction and what kind of mechanism it follows. So moving toward aldol condensation. The first condition is what kind of molecules can undergo aldol condensation. For this, there should be presence of alpha hydrogen. So look at this molecule. This is your acetaldehyde and this is acetone. This is basically the ketone and this is your aldehyde. Both have the carbonyl group. Clear? Okay. So always the carbon next to your functional group, here is carbonyl group, is known as alpha carbon. This is your alpha carbon. And the hydrogens linked with the alpha carbon are known as alpha hydrogens. In case of acetaldehyde, there is one methyl group, means one alpha carbon is there, and there are three alpha hydrogens present in acetaldehyde. But in case of acetone, there are 6 alpha hydrogens because it contains 2 alpha carbons. Clear? So why only those molecules will undergo aldol condensation reactions having alpha hydrogen? This is my next question because this is due to the peculiar property of this carbonyl group, and the carbonyl group we know this is electron withdrawing group in nature. What is the meaning of electron withdrawing? Which pulls share pair of electron towards itself. Which pulls share pair of electron towards itself. That is known as electron withdrawing group. So if the carbonyl group here will pull share pair of electron towards itself, means from here it is abstracting the electrons and this is making, this is your alpha carbon and this is your alpha hydrogen. Yeah. Due to electron withdrawing inductive effect of carbonyl group, it withdraws electron from adjacent carbon-carbon bond. This makes alpha carbon electron deficient. The alpha carbon in turn withdraws electron from this CH bond, CH sigma bonds. As a result, what happens? The electron density in this CH sigma bond decreases, which due to which this bond weakens, and from here easily any base can abstract H positive, and this makes this molecules more acidic in nature. So this is all due to the carbonyl group, because carbonyl group is electron withdrawing in nature. So first is presence of carbonyl group must. Second is only those molecules which have alpha hydrogen, from where H positive can be abstracted. Look at two another molecules. One is formaldehyde, another one is benzaldehyde. In this case, there is no alpha carbon. So these molecules have no alpha hydrogen. Look at this molecule. Here carbon form 4 bond. One is this bond, second, third, fourth. Here is alpha carbon, but there is no alpha hydrogen. So both of these molecules do not undergo aldol condensation. Only those molecules like acetaldehyde and acetone will prefer to undergo aldol condensation. So this is about the reactant, how you will choose what kind of reactant will undergo aldol condensation. Then moving to its next part, there are three types of condensation reaction. One is self-aldol condensation reaction. Okay, so what is happening in self-condensation reaction? In this, two molecules of aldehyde or ketone condense in presence of dilute alkali. Clear? So those two molecules will be of same reactant, means A plus A. Clear? If you have been choosing ketone, then you can take B plus B. Then both the reactant are same. So that is known as self-condensation. But in case of cross-aldol condensation, in this both reactant are different, such as one is aldehyde, another one is ketone. Clear? There may be two different aldehydes, A1 plus A2, and there may be two different ketones also. So when two molecules of different reactants have been reacting, that is your cross-aldol condensation. Okay. In case of intramolecular condensation, in intramolecular condensation, only one molecule is reacting. Why only one molecule will react? Because if a compound contains two aldehyde, such as this one, as this compound contains two aldehyde groups. Clear? So it can undergo intramolecular aldol condensation. So this is the condition for the intramolecular condensation reaction. There should be presence of two carbonyl groups, that may be either aldehyde group or ketone group. Okay. Then moving toward self-condensation reaction. How these proceeds? Okay, I have chosen acetaldehyde as one of the reactant, and another reactant is also acetaldehyde. So this is the example of purely self-condensation reaction. So this reaction was subjected to be carried out in the presence of dilute NaOH. This is the another condition. In this, always in aldol condensations, we use dilute alkalis. Dilute alkalis, another alkalis can also be used, such as sodium carbonate, barium hydroxide. Clear? And in this, we can't use strong base. Clear? Because strong base can act as a nucleophile and it will attack to the carbonyl group also. So you will understand this concept through the mechanism why we are not using strong base in case of aldol condensation reactions. And why this reaction is named as aldol condensation, it is very clear from the formation of intermediates in this reaction. First step is formation of aldol, then second step is condensation. Why the first step is known as aldol? Because in this intermediate is formed in which both aldehyde and alcohol group are present. That's why it is named as aldol. And what is the meaning of condensation? Condensation means removal of water molecule. And in second step, there is removal of water molecules. That's why this reaction is named as aldol condensation. So look at these two reactants in the, and it was subjected in the presence of dilute NaOH. In first step, there is formation of a intermediate that is known as aldol. This is carbon number 1, 2, 3, and 4. These two molecules are joining 1, 2, 3, and 4. This is your fourth carbon. Clear? Okay. The first is aldehyde group and the third is your alcohol group. That's why it is aldol. And this is your alpha carbon and this is your beta carbon. The alcohol group is present at beta position. And in second step, there is removal of one molecule of water and it will be eliminated from alpha position and beta. The hydrogen will be abstracted from alpha position and the hydroxy group will be removed from beta position. Then there will be formation of a double bond. Let's look at this molecule. So alpha carbon, beta carbon. So this is also known as alpha beta unsaturated aldehyde. So the final product in the aldol reaction is alpha beta unsaturated aldehyde, but the first is formation of aldol. Clear? So moving towards mechanism, as in this, we have been using dilute NaOH, that is going through base catalyzed mechanism. So NaOH is basically a base. First step is abstraction of H positive. OH negative will abstract this hydrogen from here, because I have already told you this hydrogen is acidic in nature, can be easily abstracted due to electron withdrawing group nature of this carbonyl group. So when this OH negative will abstract H positive from here, what happens? These electron will be shifted toward this CH2. Thus, with the elimination of water, it is forming a water. A molecule is generated in which this CH2 carries a negative charge. Okay, so this carbon carrying negative charge having adjacent carbonyl group, so it can undergo resonance. When it undergo resonance, then it will form enolate as an intermediate. This is your enolate. Enolate. Clear? So this is your transition state in which intermediate is formed enolate. Now, what is the next step? In next step, the enolate formed being is strong nucleophile. It will react with another molecule of acetaldehyde. When it attacks on acetaldehyde, there will be electromagnetic shift between this carbon and oxygen, and the electron will be shifted towards this oxygen molecule. And this is your carbon number 1, 2, 3, and 4. To make the more easier concept, I have just marked these carbons, carbon number 1, 2, 3, and 4. Clear? Okay. So there is bond formation between the carbon number 2 and carbon number 3. You can see here. And there is negative charge on this oxygen. And this is your oxyanion. When oxygen carries negative charge, that is known as oxyanion. This will abstract the hydrogen from water. Water formed in the first step during the formation of the intermediate enolate. So hydrogen H positive will be abstracted from the water. So when this abstracts H positive from here, then again OH negative is generated. Clear? Okay, this is your aldol, aldehyde and hydroxy group. So first is formation of aldol. The last step is condensation. Always the alpha hydrogen will be abstracted for the condensation. There will be removal of alpha hydrogen and beta hydroxy group. Then this is your final product for aldol condensation. So the mechanism explains how the aldol is formed and final product is formed. Clear? So there are some other examples also. This is your another molecule. If it is also subjected to undergo aldol condensation. This is known as acetophenone because this has also alpha hydrogen and its second molecule alpha hydrogen. So then it will follow the same mechanism. First of all, there is formation of aldol product, then undergo condensation. I am directly writing the product over here. The H is abstracted from here and oxygen from here. And look at this molecule. 1, 2, 3. 1, 2, 3. And this is your another molecule. 4, 5. And this is your fifth carbon, fourth, and this is your sixth carbon. So there is formation of bond between carbon number 1 and carbon number 5. And there is double bond. So this is also kind of aldol condensation. Here the base used is dilute NaOH. So it is very clear the base must be in diluted form. If the base is in concentrated form, base can attack on this carbonyl group. So it will lead to nucleophilic addition reactions because we don't want here nucleophilic addition reactions. That's why the base used here is diluted in nature. So aldol condensation can also undergo acid catalyzed reaction. This is not necessary. The presence of dilute base, it can also undergo acidic conditions. So this is our first molecule of acetaldehyde, how it will form the product via acid catalyzed reaction. So look at the mechanism. In first step, the acetaldehyde is reacting with H positive. This H positive is generated from HCl. Clear? This oxygen will attack on H positive and the oxygen will get protonated, acquiring positive charge on it. Clear? As we know, this carbonyl group is electron withdrawing in nature. It will abstract the hydrogen from here and further undergo electromeric shift, thus forming an intermediate known as enol. Enol. En stands for double bond, ol for this hydroxy group. So due to the formation of intermediate enol, it will further attack on another molecule of acetaldehyde. Clear? In case of base catalyzed reaction, there was formation of intermediate that was enolate. But in case of acid catalyzed, the intermediate is enol. So just remember this difference. This is very necessary because this differentiate these both species, enolate and enol. So the formation of enol promotes nucleophilic attack. So there is shift of electrons toward this carbon and this carbon will attack on carbonyl group and there is further electromeric shift. This is your carbon number 1, 2, 3 and 4. Yeah. So the oxygen with carbon number 1 now gets positive charge because it has given its electron to this carbon. Now the carbon number 3 is this. The oxygen linked to carbon number 3 thus acquires negative charge. Okay. So further in next step, what happens? This oxygen carrying negative charge will get protonated and will abstract from H positive from its adjacent carbonyl group, which carries H positive on over it. And thus, after abstraction of H positive from adjacent carbonyl group, the molecules look like this. And in final step, there is removal of water molecule. This is your alpha carbon and beta carbon. H positive is abstracted from alpha hydrogen and removal of hydroxy group from beta carbon. Thus, there is formation of alpha beta unsaturated aldehyde. So the reaction can proceed via both under basic condition as well under acidic condition. So you just have to check whether it is conducted under basic or acidic. Clear? Yeah. The next reaction is our cross aldol condensation. In cross aldol condensation, the two molecules have been reacting, but these two molecules are different. This is also aldehyde. This is also aldehyde, but both are different. Clear? This is acetaldehyde. This is your propanol. 1, 2, 3. Propanol. In the presence of dilute NaOH. So in this case, there is formation of four products. Why in this case there is formation of four products? Because there are four possibilities. How four possibilities? First of all, the hydrogen can abstracted from this reactant, and this reactant will attack on this carbonyl. Clear? This is your one possibility. Second possibility, when the alpha hydrogen is abstracted from the second reactant, that is propanol. That is your second possibility. Third and fourth is these molecule can also undergo self-condensation reactant. Means acetaldehyde can react also with itself, with its second molecule, and propanol can also react with itself. Clear? So there are four possibilities in this reaction. So you will get number of products, and the yield of product is very, because the both of these reactant have alpha hydrogens. Look at the second example. In this case, one is acetaldehyde, another is formaldehyde. Acetaldehyde have alpha hydrogen and formaldehyde have no alpha hydrogen. That's why if it is undergoing a reaction through basic condition, then the alpha hydrogen will be abstracted from this reactant, and it will lead to formation of a intermediate, that is aldol, and further hydrogen will be abstracted from here and the hydroxy group will be removed. Then there is formation of the final product. Yeah. So in this case, there is also formation of self condensation product also. So self condensation product will also be formed, but in this case, only two products will be formed. The next is acetone and formaldehyde. In this case, one we will get is cross aldol product. The second is self aldol product. Clear? The fourth reactant, benzaldehyde and acetaldehyde. So acetaldehyde have alpha hydrogen. In case of benzaldehyde, no alpha hydrogen. So in this also, there will be formation of only two products. One is cross aldol, another one is self aldol. So this was the case regarding cross aldol condensation. In these two different molecules have been reacting, but the limitation is that along with cross aldol condensation, the molecules is also undergoing self-condensation reaction. That's why in the final step, the yield become very low. The last one is our intramolecular aldol condensation reaction. So only those molecules undergo intramolecular aldol condensation reactions which have two aldehyde groups or two ketones, either one aldehyde or one ketone. Clear? Okay. So this is hexane 1,6-diol. This is your carbon number 1, 2, 3, 4, 5, 6. It has 6 carbon chain hex, and all of them have single bond in, and the aldehyde groups are present at first and sixth position. That's why its name is hexane 1,6-diol. And a aldol condensation was carried out in the presence of dilute NaOH. Of course, it is base catalyzed reaction. For base catalyzed subtract reaction, first of all, there is the abstraction of H positive from its alpha carbon. So this is alpha carbon, this is alpha carbon. So The alpha hydrogen will be abstracted from any of one carbon, either from carbon number 2 or 5. I have shown here the alpha hydrogen have been abstracted from carbon number 5, and there is negative charge on it on this carbon. Clear? The second step is nucleophilic attack by this carbon, okay, on the aldehyde. Now it is attacking on the carbonyl group, and there will be electromeric shift. The electron will get transferred toward oxygen atom, thus forming a oxyanion. Clear? Okay. The next step is the abstraction of H positive from water molecule, and this oxygen will get protonated, thus forming aldol. When aldol is formed, this is your carbon number 1, 2, 3, 4, 5, 6. Now, when aldol is formed, then there is elimination of one molecule of water. Then hydrogen will be abstracted from alpha and hydroxy from beta. So this is your alpha beta unsaturated product. Yeah. And what is its IUPAC name? This is cyclic in nature. So cyclo. And in this cyclic chain, there are 5 carbon. For that, we are using pant. And the double bond is present at first carbon in, and this aldehyde group is present outside the ring. That's why it will be used as suffix, that is carbaldehyde. So its name is cyclopent 1 in carbaldehyde. So this was all about aldol condensation reactions. Clear? So it's very important to remember two things. One is presence of alpha hydrogen. The second one is whether it is carried out in dilute NaOH. And third one is dilute acid. Clear? So if you see in any reaction these conditions, then it is aldol condensation reactions. So I am giving you two questions. Here are two molecules of aldehyde. One is ketone and aldehyde. You have to write the product over here and by following the mechanisms. This is your question based on our previous lecture. And if you like this video, please share and subscribe my channel. If you have any query, then you can pin up me in the comment section and I will answer you. If you have any query related to other reactions of carbonyl, then you can also ask from me through the comment box. So thank you for today's lecture.